Welcome to the Denver MuleSoft Meetup, hosted by the integration lovers at Big Compass. In today's meetup, we are joined by Brian Statkevicus, the MuleSoft Practice Manager at Big Compass, and Connor Fitzgerald, a Senior Consultant at Big Compass. Together, they will do a deep dive into MuleSoft's Anypoint Runtime Fabric security.
Thank you very much, Brian. Again, I'm Connor Fitzgerald with Big Compass, and I am a solution consultant. And today I'm going to talk about the Runtime Fabric. The first things I'm going to answer are exactly what is Runtime Fabric, what are the deployment options, and what are some of the benefits. So to start, Runtime Fabric is a container service that allows you to run Mule applications on self-managed resources while maintaining a centralized management via Anypoint platform. And that is because basically you're spinning up the runtime plane on your own hardware or infrastructure, while the control plane is still owned and managed by MuleSoft. So anything you were doing before with, let's say, CloudHub. So if you're deploying to CloudHub from Runtime Manager, for Runtime Fabric, you're still going to deploy from Runtime Manager. For deployment options, as far as where you're going to host your Runtime Fabric, there's basically two main options. One would be on a cloud VM or even your bare metal servers. And the second would be a Kubernetes service, which are provided by people like Amazon, Azure, and Google. Some of the benefits are that it's high availability, fault tolerance, and scalability, and provided by the Kubernetes, which is under the hood for Runtime Fabric. You can support zero downtime, where you have rolling updates across your replicas, and then everything is still, again, managed from Anypoint platform. So things like log forwarding, you can set up to send back to Anypoint platform. One of the highlights today is going to be the newly added deploying to Kubernetes service. So again, whether you're deploying to your own bare metal servers or an EC2 instance, under the hood, Runtime Fabric is really just a container Kubernetes service. And so what they recently added is you can spin up your Kubernetes service on, again, Azure, Amazon, or Google. And then what I like to think of it as is MuleSoft giving you the keys to your own runtime plane. And again, you own the infrastructure here, so you have complete control and configurability in terms of what's going on there. Let's talk about MuleSoft's roadmap here. To begin with, you could only deploy to virtual machines and your on-premise bare metal servers. With that installation process, Docker and Kubernetes were both installed on your, let's say, EC2 instances. And then what was added is the ability to, again, deploy directly to your Kubernetes service. This is going to be much more lightweight, lower overhead, and easier to manage. We'll get into the benefits a bit more later. And then continuing on, MuleSoft is continuing to look for the ability to deploy to these Kubernetes services and supporting additional ones such as OpenShift. To talk about exactly how it works. So here we're focusing mainly on the appliance version. And the appliance version is going to be those deployments to things like EC2 instances in your bare metal servers. It's a bit more heavyweight, but it comes with everything you're going to need to run your applications. Again, the customer is responsible for not only provisioning, but also maintaining and managing the infrastructure that Runtime Fabric is running on. But MuleSoft still owns the control plane. So it's going to handle things like deployment, the orchestration of these services. Within the installation, Kubernetes and Docker are installed there to handle the orchestration. For deploying to a Kubernetes service, again, it's much more lightweight, but you do have some additional things that you have to take care of. Whereas the appliance version is going to come with your ingress controller, your load balancer, and log forwarder. Well, the Kubernetes service, you just show up with your Kubernetes service, and then Runtime Fabric deploys on top of that. And then the housekeeping items you have to do, again, are the ingress controller and external log forwarder. But MuleSoft does make it easy. Like, it's not required to have Kubernetes expertise to be able to spin this up. It just makes it, or unlocks additional configuration and customizability. So as a high-level architecture of the appliance version, for production deployments, MuleSoft recommends 3 controller nodes and a minimum of 3 workers. So these controller nodes are going to have your load balancers and your MuleSoft agent. The MuleSoft agent is what's going to talk back to the control plane. And so let's say you go to deploy from Runtime Manager, that's going to talk to the agent on your controller node, and the agent from there is going to deploy the application to your worker node. And within Runtime Manager, when you're deploying these, you're going to set up the resource allocations. And so you'll provision a certain number of vCores and memory there, and then the agent is automatically going to determine which worker node has the resources available for that new application. Additionally, in Runtime Manager, you're able to force the agent to deploy your replicas across multiple nodes. This way, if you have 3 replicas of the same application, you can ensure that that's going to be on 3 different worker nodes. So in case one of those, a single worker node goes down, you still have the 2 additional replicas that are going to be able to service those requests. So a consumer of that application would not see any downtime. Again, with the Kubernetes service, it's a bit more lightweight. So everything to facilitate the runtime fabric is going to be existing in your Kubernetes service. Your ingress controller does not come with installation, but the Kubernetes service providers such as AWS allow you to deploy those to your service, and then MuleSoft provides the documentation on how to configure the ingress controller into your applications. And again, the agent is still going to exist inside the Kubernetes service, and that's what's going to be communicating with the control plane. Some of the benefits of the Kubernetes service especially are the lower cost, and that's because, let's say the production configuration recommendation for the appliance version, you need to have those 3 controllers running all the time, and that can run up your bill. Whereas with the Kubernetes service, it's going to be much more a model of where you're paying what you're using. So these things are going to auto scale up and down as the request. And with the appliance version, MuleSoft kind of intentionally abstracts away a lot of the Kubernetes and Docker parts. So you don't need to have any experience with those or get your hands dirty in Kubernetes, but you have much less flexibility and customization there. Whereas with the Kubernetes service deployment, you're at a much lower level and provide way more customization options. It's much less overhead, like we were seeing, where you don't have controller nodes and worker nodes, and you need to make sure that the communication between those is working. Continuing on the comparison between the two, obviously the Mule applications and API gateways can be deployed to either option. In terms of Kubernetes and Docker, again, the RTF appliance, these are installed when you're installing the RTF appliance, and MuleSoft provides several installation scripts to be able to do this in both AWS and Azure, as well as a manual deployment option. And then with the Kubernetes service, obviously you're already providing the Kubernetes resources, and then the MuleSoft installation is just going to install Docker. For the appliance version, only Red Hat Linux and CentOS are supported. And technically, the RTF appliance does not support node autoscaling, but it does have this thing called bursting, where let's say a single worker node has 1 CPU. Well, when you deploy an application there, you can reserve 0.1 CPU for that application, but you can also set an upper limit. And let's say we set that upper limit at 1 CPU. So there's going to be 0.1 allocated, but that worker node, or not that node, but the replica can actually scale up to the upper bound that you set. But with the Kubernetes service deployments, you can use your Kubernetes service provider to configure node autoscaling. So as you're servicing more and more requests, your nodes are going to autoscale as well as replicate. For external log forwarding, if you're using the appliance version, you have to have a Titanium subscription to be able to forward those logs back to Anypoint platform. However, it does have out of the box support for things like Splunk. And then for Kubernetes service, there is no log forwarding provided. The customer must set up their own there. And again, I think we touched on this earlier, but for the internal load balancer, the Kubernetes service installation does not come with one of those. You'll have to set it up completely yourself, but it is included in the RTF appliance. because it's included in the RTF appliance, you are able to apply the Anypoint security edge policies from Anypoint platform. And then RTF appliance comes with something called Op Center. And additionally, what's installed is the Elk stack. So through Op Center, you're able to look at things like the logs. You're able to configure a few parameters, and you can also view usage metrics in terms of your CPU and memory utilization, all from Op Center. But that's not included in the Kubernetes service deployment. And then the recent feature for the persistence gateway is supported on both of those. And then for our trivia question, we have which of the following do VM bare metal RTF installations provide that self-managed Kubernetes do not? And Rajesh Ale got that one right. It is D, resource and infrastructure monitoring via Op Center. Again, that's not included with the self-managed Kubernetes option. And with that, I'll turn it back over to you, Brian.
All right, let me share. Present. Helps if I share my screen, huh? Cool, so congratulations, Rajesh, for being the first correct answer on Connor's trivia question. If you could send us your email, we will, after the meetup concludes, forward you the Google form that you can complete to go and get your voucher from MuleSoft. So Connor, thanks once again for an excellent overview of Runtime Fabric and the differences between the appliance version and the Kubernetes service versions. The demos that you're going to be seeing a little later on tonight are all running on the appliance version that actually Connor himself has set up on one of our AWS instances. So now what we're going to do is focus on Runtime Fabric security. And we're going to tackle Runtime Fabric security kind of in a top to bottom fashion, starting with what are the best practices to secure your runtime network security network. Again, that's going to be the appliance deployment. We're going to focus a lot on securing APIs. We're going to talk about securing credentials. And then we're also going to talk about how to secure data through the tokenization service, which is only available on Runtime Fabric. Let's go ahead and get started with the Runtime Fabric network security. This is basically the configuration that Connor has already shown with just a few more network details in it. And this is also MuleSoft's recommended configuration. Again, in the diagram here, we have 3 controller nodes. Again, as Connor mentioned, that's to ensure fault tolerance. And we also have 3 worker nodes. This particular example, you see a request is incoming. It goes to an external TCP load balancer. The load balancer goes ahead and forwards the request to the internal load balancers. The internal load balancer that it finds will go ahead and find an available replica of a Mule application on one of your worker nodes, decrypts the message, sends the request to the application, in this case a ping, and the application decides to send back a pong, not the video game Pong, if anybody gets that reference, but just a response to the ping message. And that goes back to the internal load balancer, back to the TCP load balancer, and back to the consuming clients. You'll notice that in the IP addresses here, all the nodes are on the same subnet. This is MuleSoft's recommended configuration. Helps handle latency. There shouldn't be that much latency, and it's also certainly a simple network. Now, clearly, there are some of you that may have to rely on private and public subnets. You would have to go ahead and most people who are using private and public subnets will put their controller nodes on the public subnet and their applications on the private subnets. So based on this question, based on this, I'm looking at the chat and I see a question. Based on this diagram, again, some of the best best practices, just open the IP addresses that you're required to be open. I mean, that kind of sounds like obvious, but sometimes the obvious is missed. Ensure that you're only opening the ports that you require. HTTPS is typically 443, it could also be 8092. Use the external load balancer and make sure that your ingress communication, which you configure in your Runtime Fabric deployments, is limited to a trusted source. And again, I already talked about private and public subnet models. Just be aware you're going to deal with latency across your subnets. There's a question that came in. I'm not sure what the answer is. Connor, I'm going to ask you because I'm going to put you on the spot here. The question is, can we have an AWS load balancer on top of the controller, the TCP load balancer?
Yes, for the appliance version, you can specify an external load balancer that's going to feed into the actual RTF instance. And then for the Kubernetes service version, you have to configure the TCP load balancer separately.
Great. You're welcome. Thanks for that answer, Connor. So that's all we're going to talk about in terms of network security. Again, usually when you're deploying RTF, whether on your appliance or whether you're doing a Kubernetes service deployment, obviously get your network team involved. They know some of the best practices. It's always a good idea too to maybe have somebody in your organization trying to detect any vulnerabilities in what you've configured before you start opening up your systems to external traffic. We're now going to get into API security. The best practice with API security is to use multiple levels in order to go ahead and protect your APIs. Similar to what you may see in American football, the defense is usually in multiple layers. Sometimes they'll do an all-out blitz, which means the cornerbacks are one-on-one, and if the receiver gets behind the cornerbacks, you're doomed. You're going to have a big play. Or for those who follow soccer, you can consider that similar to a high line. That requires a lot of coordination. If somebody does not communicate correctly with a high line, all of a sudden you have one-on-one against the keeper, which never ends well. So again, analogous to sports, with your APIs, you should have the best practices have multiple layers. Obviously, the drawbacks here, depending on what component you're using, this could be pretty costly, not only in terms of a deployment cost or a component cost, but also now you have to maintain multiple skill sets within your organization. And of course, every layer you add is going to impact your performance. So you have to balance the cost, the impact to your performance versus how secure you really do make your APIs. And obviously, for those of us who live in the US, especially along the East Coast, we all know that a major pipeline was hacked into recently, and that disrupted gas supplies along the East Coast. So security is always important. So we're going to go ahead and review how you would implement these layers of security. The first one is using an API gateway. And this is going to prevent, or protect, I should say, against brute force and other types of simple attacks. You could do rate limiting here. You could certainly do IP whitelisting, blacklisting. You could also detect, enforce a client ID in secret or OAuth, whatever you want to do. Basically, this is providing the basic security for your APIs. And this is, to me, this is like the minimum. If you're not doing this, you're just asking to be hacked, quite frankly. The second layer is applying a WAF or a RASP. And this is WAF, of course, is Web Application Firewall. RASP is Runtime Application Self-Protection. The OWASP has the top 10 attacks, and I provide a link there in case you're interested in finding out a little bit more about those. When you combine this with the API gateway, that gives you a second level of protection. You're going to protect against XML threats, denial of service, SQL injections, et cetera, those types of common top 10 attacks. Some of you who are listening may be like, well, wait a second, MuleSoft does all this in Anypoint in API Manager, and that is correct. And I will get to that in a second, how you would implement these layers with MuleSoft. So finally, we have the third layer, and this is really the emerging layer of API security, is the machine language or artificial intelligence layer. So far, yeah, we've prevented SQL injections. We may have done IP whitelisting. But what happens if somebody has, for example, Connor's credentials and they look good to us? Like, let's say Stephanie, who can be very nefarious at times, has stolen Connor's credentials. And she's going to log in as Connor and try to consume an application. Well, your backend is going to authenticate. So, okay, Connor's credentials look good, and authorize Connor to go do what Connor's normally allowed to do. And Connor normally goes and queries the employee database, but he queries one employee at a time, or maybe himself or something. Whereas Stephanie is querying everybody in the database. And then she's going to take that information and do something nefarious with it because she just is that way. Of course, I'm teasing her, but she can't say anything right now. But that is a problem, and that is where the concepts of zero trust security come in, and that is where ML/AI solutions can help protect. And again, ML/AI helps you detect deviations from normal behavior. Again, you would see Connor, instead of getting one employee, he's getting the whole thing. Well, wait a second, Connor never actually does that, or maybe shouldn't be doing that. So this is going to protect you against the insider threats, when tokens and credentials are stolen, basically nefarious people like Stephanie, who is probably hacking into my account right now as we speak, since I'm giving her a hard time. So let's go ahead and talk about how we would implement these policies, and we are going to demonstrate. I'm going to demonstrate this shortly. So with Runtime Fabric, you can see on the right-hand side, you still have the API management policies, which some of you may be familiar with, and we'll have one of those in one of our APIs deployed to Runtime Fabric. And then also we have something called Anypoint Security. Anypoint Security is used to apply what we would call edge security policies. I'm going to demonstrate one that demonstrates whitelist. I think Connor has one that demonstrates WAF. I don't think we're doing denial of service. The main difference between these two policies is edge security is going to affect all your APIs deployed to Runtime Fabric. If you need to be more granular than that, you could, of course, use the API management policies that you're familiar with. What Anypoint Security does not do is it does not provide the ML/AI layer of protection. I will show you an example of that with a custom policy that one of my team members is currently working with one of our partners to use one of those ML/AI solutions to really add that third layer of security. And just be aware, as Connor mentioned previously, Anypoint Security is not supported on the Kubernetes service deployments. So I've talked about network security. I've talked about API security. We will be demoing a lot of this. Now let's talk about how do we keep our properties at rest. The challenge, as all of you know, is that when you're integrating with enterprise information systems, which is basically any system you have in your enterprise, whether on-premise or in the cloud, that you need to expose data from that system to the outside world. They're going to need credentials. Now, usually in integration solutions, we use what we call service accounts. Service accounts are pretty close to pseudo type of accounts, and they're definitely something that you definitely need to protect, and you may need to maintain these credentials, like change them every 90 days or something like that. You may also determine that you want to go ahead and secure. You may also want to determine if you can go ahead and secure some other information like URLs, IP addresses, et cetera, that it probably shouldn't be in plain text, because that's opening up somebody to try to see, okay, where is this enterprise weak? Never, ever, ever store these credentials in plain text. That's kind of it's obvious, but you'd be surprised what I've seen in my career in integration. So how do we go ahead and solve that problem? There's two main ways to do this. A lot of you are probably familiar with secure configuration properties. The URL here is the 4.2 version of the jar file. It should be a 4.3 version also. You also have to download this, you use your favorite command line tool. It also requires the Mule secure configuration property extension. Again, you have the option to go ahead and encrypt individual properties. You can encrypt all your properties, and you can go ahead and encrypt the entire content. The nice thing about secure configuration properties, it does work with both the YAML and properties files. You have to have the key, and you can see here in my example configuration, and what you'll see in the demo is that, well, actually, no, not here. I'll show you the demo where you're prefacing your properties with secure. Now, some of you who've been working with MuleSoft for a longer time may be familiar with the Premium Security Connector, and that's at the Amazon AWS site. This feature is no longer documented officially by MuleSoft, so we consider it unofficial now, and we won't cover that in this presentation. And then the second option available is what we call safely hidden application properties. For those of you who are familiar with CloudHub, you may be using these in your enterprise. The nice thing about using safely hidden properties is as follows. The secure configuration properties sooner or later are still going into a YAML file which means they're going to be in your GitHub repository, in your repo, whether it's GitHub or Azure DevOps or Bitbucket or whatever it is. So you're still kind of having these properties around, and oh, by the way, if somebody gets the key, they could decrypt pretty much anything. Safely hidden application properties solve that problem, is that you can go ahead during deployment time, you specify in your Mule artifact.json which properties you want safely hidden, and then you go ahead and during deploy time, those are going to be safely hidden. However, just be aware this is a little bit different on Runtime Fabric, and I will show you that. You have to actually use a command line utility RTF control from Ops Center. I'll show that. But just be aware, I can still get at these properties. I've mentioned consider injected properties, especially with CloudHub. That's a really good way to secure the properties. So before I get to the demo, it looks like I do have a question here. I have two questions. How to protect sensitive, yeah, DW mask is certainly one way to do it. Connor's also going to discuss tokenization, which applies to RTF. So he will be talking about that and demonstrating that shortly. The other question is, without API Manager, can I still use edge security policies? That is an excellent question. I don't know the answer to that. I don't believe edge security requires API Manager for that. So my guess is yes. Rajesh, we have your email answer. Stephanie, could you take a note to say we want to get back this answer? I know exactly what you're asking, and I don't know what the answer is with in terms of how MuleSoft licenses that. But that's a great question. So now what we're going to do is, I've been talking a lot, so let's actually show some stuff. So I'm going to go ahead and show you how to do secure configuration properties. I'm going to talk about safely hidden properties, both on CloudHub and Runtime Fabric. And then we're going to test with some edge security and API Manager policies. I'm going to spare you the boredom of watching me deploy to Runtime Fabric. So you're just going to have to, well, I'll show you in Runtime Fabric, I have my applications already deployed. So what I'm going to do is get out of the slide and go, first of all, I'm going to kill my camera here because I'm going to have to lower my screen. I'm going to go to Anypoint Studio. Note with Studio 7.9, there is a dark theme. I don't know if any of you have experienced a dark theme. I still have not joined a dark side. I prefer to see the light. Maybe it's just I'm just used to it, and I just struggle to adopt a dark theme. So I'd be curious if anybody's adopted a dark theme and what they think of it. So what I have here is I have my database configuration. And right now I have my host, my port, my user, my password. So I'll show you. And my database secured, but my user right now is in plain text, which means that it's going to be in wherever my properties YAML is. And you can see here my secure properties, that's where everything is, that's where all my values are encrypted. But let's just say somebody says, you know, I tell you what, we don't want anybody to know what our service account user ID is. Let's go ahead and encrypt that. So what we do over on our favorite command prompt, in this case I'm at my DOS prompt, is I'm going to go ahead and say, I already have, as you can see, I have the secure properties tool.jar file. So I'm going to go ahead, type in correctly, Java cp secure properties tool.jar com.mulesoft tools.secure properties tool string encrypt. It's important that when I'm encrypting my property, I'm going to go ahead and pick up the correct algorithm as specified in my connectors. I will show you when I go back to my globals. No, it's not here. It's going to be in this guy, the secure properties configuration, which algorithm am I using and what modem I'm using. I need to reproduce those. So as you can see from my configuration, I'm using Blowfish, I'm using CBC. So I will go ahead and encrypt with Blowfish algorithm CBC. Then what's my key? My key in this case should be my user. So it's going to be mysql.user. And I'm sorry. This should actually be the decryption key, not that. And then the value, which is going to be Big Compass. And it goes ahead and returns the encrypted version of Big Compass. So here's the key. Of course, this is my decrypt key, and here's my value, and then I use that. So basically what I will do is I will change my user and my configuration to secure, MySQL.user. I'll come back to you. Go ahead and give me your little error. I know I have to go ahead and change my configuration. I will go to my secure properties. I will uncomment this out since I've already tested this out and this is a demo. Go ahead and save that. And then I can go ahead back into my globals, go into my database configuration, and go ahead and test it out to see if it's going to work. And sure enough, it worked. Now, one caveat to using the test connection with the database adapter connector for that matter, any of the connectors, is I had to go ahead and configure my decryption key as a global property. So some of you will instead say that's not a great practice. Go ahead and do it when you're debugging it. So you provide the key as a debug configuration parameter. So you just go into your arguments, put your decryption key here, and you can go ahead and test it locally. So just be aware that I had to use this in my global configuration elements. Do not check this into your version control solution with this global property defined. So that is just to quickly show you how to go ahead and encrypt the properties. So let's go ahead and see how we do safely hidden properties both on Runtime Fabric and on CloudHub. So for those of you who are familiar, whoops, let's go back to Studio. So if I want to go ahead and safely hide a property in CloudHub, I'm going to go ahead to my Mule artifact.json and create a list of which properties I want safely hidden in CloudHub. In this case, I'm saying I want my decryption key safely hidden because I don't want anybody getting a hold of my key. So if I go into Runtime Manager, and I go and take a look to see which one I recently modified, my Pokemon DB from CloudHub. If I go to my settings of my application, I go to properties, you can see here my decryption key is safely hidden. I cannot edit this. I can't see what this currently is, so the only thing I can do is go ahead and edit it. So I'll just put this back in here. It pastes in. As you can see, I still haven't seen it. So the advantage of using safely hidden properties, yes, I'm not encrypting the value of the key itself, but nobody has seen my key. So that is a little bit better way to secure it. So how about on Runtime Fabric? How does it work on Runtime Fabric? Well, let's go take a look. No, we're never going to save that. So what I have here is I have two versions of my application deployed to Runtime Fabric. I'm calling this one unsafe because when you go to Runtime Fabric and you go to properties, you can see here the decryption key is right there. It does not use safely hidden properties in Runtime Fabric the same way it does in CloudHub. So how do you get around this problem? Well, you get around this problem using Ops Center. So what you do is you would go ahead, log into Ops Center. Go to your servers, pick your controller node, log in as root. And then I'm going to go ahead and just change over to user. It's our home, EC2 user. And what I would do is I would do sudo, basically what I had on my screen before, is I would go back to this and go ahead and enter the command sudo rtf control, apply secure property, key my key value and which environment do I want to go ahead and apply this to. Now, just be aware, I've already done this. So what I'm going to do is show you how I can actually get access to that key. Which environment do I want? And you can see here, I've already created my decryption key and I have a value here. So again, be aware, you could still get at the key and the value, and you have to have root access. So hopefully you know who has root level access to Runtime Fabric. So it is still there. So it's kind of sort of safely hidden with Runtime Fabric. So far what I've done is I've shown you how safely hidden properties work both in CloudHub and Runtime Fabric. They are a little different. Just be aware of the differences. So let's go ahead and test. What I'm going to do is I'm going to go ahead and do some testing and show some API manager policies. So the first thing I'm going to do is I'm going to go ahead and hit my application, which is deployed to Runtime Fabric. So I'm going to be hitting this application on Runtime Fabric. You can see my deployment properties. There's no decrypt key. I have that safely hidden kind of sort of on Runtime Fabric. So I'm going to be going ahead and hitting this application URL. Let's go ahead and hit send. Whoops, I hit a policy somewhere. So the policy I hit is an API manager. So I'll go to API manager. I'll find my Pokemon to DB. And sure enough, what do I have in my policies is I have basic authentication set up. So let me go ahead and enable basic authentication. First of all, what I'm going to do is I'm going to go ahead and open up Runtime Manager in a different tab. So I'll have to go back to it. So I'm going to go ahead, apply my basic auth. I have my username and password. I'm going to go ahead and hit send. And sure enough, the application does work. So let me show you how to apply an edge policy on Runtime Fabric. So let me go over to my Runtime Fabrics. I'll go over to Runtime Security Meetup. I go to inbound traffic. As you can see here, we have some security policies set up. Where do we set these security policies? We set these security policies in using MuleSoft Security. MuleSoft Anypoint Security is the edge security policy. So we can see here is I called something called RTF allow. Here's my whitelists of the IPs I'm going to go ahead and allow to access my applications. So I use Anypoint Security to configure the edge policies. Then I go to my Anypoint Management Center and I say, I want to go ahead and apply my IP allow list, in this case, RTF allow. So I'm going to go ahead and save and deploy that. It's going to go ahead and apply this. Remember, this is being applied to my entire appliance deployment in this case. So my entire Runtime Fabric is going to go ahead and get this applied. I could see it's been applied. Let's talk amongst ourselves for a minute while it actually really gets applied. Wait, I see in my email, I'm getting all these nasty messages. I think Stephanie went and hacked me. That wasn't nice of you, Stephanie. All right, let's see if we can go ahead and test this guy out. Whoops, could not get the response. Why couldn't I get the response? Because the IP address where I'm sourcing this, where I'm running this test from, is not whitelisted. So basically, again, I've showed you, I've applied an edge policy that is whitelisting my IP address. I provided that I configured it, the policy, in Anypoint Security, which I showed you. I had these in my Cedar addresses that are my Cedar. And then I went and I applied it to my inbound traffic, and then I ran it and it didn't work. So again, Rajesh, I'm going to get you an answer for that. I have a feeling you can get away with doing this without API Manager, but don't quote me on that. I'll get you the actual answer as soon as I can. So I have shown you a lot so far. I've shown you API management. I've shown you safely hidden. I've shown you some safely hidden properties. So let's go ahead and talk about, well, how, I mentioned, like Brian, you mentioned something about AI/ML. Well, how would that work in MuleSoft? So that's possible through the custom policies. So what you do with custom policies is, let's go back to one of our applications here. And I know which one we're testing on this. We're testing this on this application called Listener Logger. And what they have here is they have a custom policy that's set up, happens to be working with a company called Envision, which they've set to be AI security. So if I take a look at this security, if I'm looking at this custom policy and I go and edit it, this particular policy has only one configuration, and that is the address of the AI/ML server. So you're just going to have to trust me on that one. What you normally do is you post your custom policies to Exchange. As you can see here, that's the particular policy that we have posted. Yeah, it's not very well documented, so it should be documented a little bit better. So what the policy looks like in MuleSoft is as follows. It kind of sort of almost looks like a MuleSoft flow, but it's not a true MuleSoft flow. You actually, the person's working on this, you actually have to go into the XML and go ahead and edit the XML. So you can see this particular policy, what it's doing is when you have this step, you have HTTP policy proxy and a source. This is going to apply to the inbound traffic. So what this particular policy is doing, it is basically just taking the information, the correlation ID, the URL, whatever request headers are, and the body itself. And it's going to send it to, in this case, the Envision server, which is going to take a look at that information. It's going to return back a code, which if this policy implemented it, which it did not, it would say, okay, if I got anything other than a 200, I'm probably going to reject this. But it may say, no, this looks okay. I see Connor, he's going to go query every employee. Yeah, that's okay, because I don't know any better yet. And then what happens is anything in the policy, which is after execute next, is what do I do with the response? So the response is now going to the ML AI server. And maybe this response may see a lot of employee information, and maybe there's something in the server that says, wait, no, this isn't allowed. I'm going to stop this right here, return back something other than a 200, and then that's up to the policy to implement what you do. And that would just simply be done with a try blocker or a case within MuleSoft. So similar to what you'd be normally doing with the MuleSoft flow, just be aware that you have to edit the XML directly. So hopefully everybody has been able to follow me. So we'll go back to our regularly scheduled program. And I will summarize what I just showed all of you. I saw how you locally encrypt the property. I showed you how to test it directly from the connector configurations and the pitfalls of doing it that way. I think a lot of developers will just prefer not to set the global property, because then you better remember to take it out before you go ahead and push your code to your repo. I showed you safely hidden properties on CloudHub. I showed you safely hidden properties in Runtime Fabric. I talked about edge security policy. I talked about API Manager policy. I showed you how you can implement a custom policy for an AI ML solution. So basically how you can implement 3 layers of security on your APIs deployed to Runtime Fabric. Again, if you have any questions about what I just showed you, please go ahead and send them in chat. Otherwise, it is time for trivia question number 2. Trivia question number 2. What is the most secure way to hide sensitive configuration properties? The options are here. Please go ahead and answer in chat. All right, I'll stop with the Jeopardy music. People are answering. So Rajesh, I want to congratulate you again, but you've already won once, so therefore you're disqualified from winning again. The correct answer is, however, D. So it looks like Luke Hamilton is the first one I see in chat. That is the correct answer. So let me explain why. Secure configuration properties, again, that's a good way of doing it, but you're putting those properties into your repo. Somebody gets a hold of your key, they can decrypt all your properties. Safely hidden properties in our runtime fabric are also a good way of doing it. Again, you can still get at them. Safely hidden properties in CloudHub is a really, really good way of hiding your properties. Yes, you're not decrypting them, but once you enter them, you can't get at those. However, your company, your enterprise may say, I want to limit the amount of people who have admin access to my CloudHub. That's where all my production deployments are. I don't necessarily want that to happen. I don't necessarily want to give somebody to enter properties admin access to my production environment. That's not a good idea. So my opinion, and actually a lot of other people share this to me, if you can inject your properties as part of your CI/CD tools, that allows those tools to have to keep the file secure. Again, one of my customers uses Azure DevOps to do just that. That limits who has access to my production environment, and I can secure them using Azure DevOps, which probably means I'm using my existing AD solution. That is the absolute best way to safely hide sensitive configuration properties. So again, Stephanie, I think the winner here is Luke. Again, Rajesh, you were first, but you've already won, my friend. So you can't do it twice. So with that, I'm going to turn it back over to Connor. And Connor's going to talk about how to encrypt data with the tokenization service.
Thank you, Brian. All right. I promise I'm going to talk about tokenization service now. It's important to note that tokenization service is only available for RTF applications currently. So what exactly is tokenization? At its core, it's similar to something like hashing or encryption, where you're trying to obfuscate or scramble sensitive information before you pass it to downstream systems or store it at rest. The main benefit of tokenization over something like hashing is that tokenization is format preserving. So if you're working with something like credit card numbers, as that credit card number comes in sensitive plain text, it'll be passed to your tokenization service. And then what's returned is a token that looks exactly like your credit card number, but this token is extrinsically not vulnerable or exploitable alone. And so you can safely pass that to downstream systems and expose it to whoever you want. For the tokenization service, it doesn't come out of the box with RTF installations. You have to separately configure that, but you do that through Anypoint platform, and then you also deploy it to your RTF instance through Anypoint. Some of the benefits are that it's reversible, but also vaultless. The benefit of it being vaultless is that there's two benefits there, I guess. One is that if a bad actor does gain access to your RTF instance, there's not going to be like a lookup table or something like that where the hacker can go in and find the original sensitive information in plain text. Additionally, because we don't have a vault or lookup table, your memory footprint does not scale with the number of tokens that you have provisioned. So it is highly scalable. Additionally, as you provision resources to your tokenization service, either horizontally or vertically, you're going to see linear performance gains. There's a lot of flexibility, especially in terms of the formats that it supports. So out of the box, MuleSoft provides support for things like credit card numbers, social security numbers, and email addresses. You can also create your own custom formats and even customize those default built-in formats. So there's two ways you can utilize the tokenization service. One would be to expose it as a service directly to your RTF applications, and the other being applying it as a policy through API Manager. So what you'll see in the demo is two tokenization those are both configured in API Manager and deployed from API Manager. So in API Manager, you can configure a lot of different things, specifically the selector expression. And that selector expression is going to be a data weave expression to tell the policy where to get the data to tokenize. It's important to note that this can only be applied to information within the payload. You cannot tokenize something like a header or query parameter. You can configure whether tokenization should occur on the incoming request or outgoing response. So there you can have sensitive information that gets tokenized as soon as it hits the gateway and before it passes it onto your MuleSoft application, or you can do it in the response. So let's say you want your application to handle that sensitive token, but in the response, you want it to be tokenized. And then you can configure several different formats. So while you're an API manager setting up your tokenization policy, you can specify tokenization to occur on an email address, social security number, and credit card if they're all in your payload. To kind of tee up the demo, I'd like to paint a picture of a good use case for tokenization. So let's say that we have an orders system, and coming out of that orders system are credit card numbers and the charges associated with those credit card numbers. And your goal is to maintain this ledger. And so the primary key for each of your accounts is going to be that credit card number and the charges associated with that account. But you want this ledger, you want to be able to expose it to downstream systems or downstream lines of business. So let's say your finance team wants to be able to draw insights from charges on your customer accounts. Well, you can safely expose this ledger to them and they can draw insights from there. So what we're going to see in the demo is first, like I was saying, the tokenization proxy API. So we have that sensitive card number coming in. It's going to pass it to the tokenization service immediately and get that non-vulnerable token back, which is going to be in the exact same format as the credit card number. That's going to pass it to our credit charge tracking app, which is just updating or inserting into the ledger. And then for the use case here, let's say that our model is that we accept charges all month long, and then at a certain frequency or at a certain dollar amount, we want to actually execute the sum of charges on that card. And so you can expose your ledger to your payment processor. And let's say they are the only ones with the keys to your detokenization proxy. And so they're going to take the non-sensitive token out of the ledger and we'll pass it to the detokenization proxy. Again, the main difference, other than this one being a tokenization proxy and this one being the detokenization, is that this proxy is not going to detokenize until it gets the response. So you have the non-sensitive information coming in, and it's going to pass that to, let's say you have a payment tracking app. So you want to either have an audit report or an alert for whenever your payment processor is going to actually execute a charge on there. Well, here you can pass that token to your tracker, and that can do whatever you need to with it. And then on the response, only then is the sensitive original credit card number going to be returned to your payment processor. So to queue up the demo, we're going to be talking about those tokenization and detokenization policies. And we'll also see a quick demo of the web application firewall, but we're not going to go too much into the tokenization service deployment and format configurations. I will like to go in here and look at setting up the tokenization formats. So in Anypoint security, you're going to configure your format, and the data domain is going to be those provided formats that MuleSoft supports. And again, you can further customize those. So let's say that you wanted to preserve, if you're dealing with social security numbers and you wanted to preserve the last 4 digits, you can specify that here. You could also specify masking of certain values with whatever character you want. It is important to note that if you are masking any of the value, then you can no longer detokenize it. And MuleSoft also provides, with this built-in format, it's able to validate the credit card. So if you pass in a credit card number that is not a valid credit card number, you're going to get a response showing you that it's not a valid credit card number. But you can also specify custom formats here. So to start with our tokenization, let's say coming out of that orders API is our plain text card number and the charge associated with that. So we'll send it, and this is going to update the ledger. So if we look at the ledger, we can see that that account, again, here's the sensitive card number, and then the token is the primary key in our ledger. And we'll see the charge amount get updated to 300 now. And so let's say 300 is the amount that we want our payment processor to actually execute the charge. So your payment processor is going to pull out the amount to charge as well as the card token out. And then you'll have the detokenization proxy, which you're going to provide the token. And then that token, again, is going to get passed to your audit app. So you can create a report or an alert saying that this token is about to be charged whatever dollar amount. And then when the credit card number is on its way back through the detokenization proxy, it's going to extract from the response this value and convert it to the original sensitive credit card number. And so we'll see how that gets turned back into the original card that we provided. And again, we have, for the web application firewall, we have that applied to the entire RTF instance. And so let's say someone's trying to go after our ledger by doing a SQL injection attack. You can see that if we send the request with any SQL in the query parameters, that our web application firewall is going to go ahead and reject that request. And same with cross-site scripting attacks. So anything for cross-site in the query parameters is also going to be rejected by the web application firewall. That will get to the trivia question. So which of the following is true? It looks like Canara already got that one. You can specify certain portions of the data to be preserved, masked, and things like that when you're customizing your token format. And with that, I'll pass it back over to you, Stephanie.